po, so today we'll discuss diagonalization of symmetric matrices. So first, what do we mean by symmetric matrices? So when you say symmetric matrices, a matrix A is symmetric if A transpose equals A. If A is equal to the matrix A sub ij, then A sub ij is equal to A sub ij for all A sub ij. For example, I have here matrix A, B, C, D, then A is symmetric if B is equal to C. So, itong element ni B ay pareho sa element ni C, sa element C. So, for example, I have here a matrix 1, 3, 3, 2. So, this is a symmetric matrix because ito nga, si 3 and 3 are equal. Okay. So, how about if we have 3 by 3 matrix? So, then A is symmetric if B is equal to D, C is equal to G, and F is equal to H. Like, for example, I have here a matrix which contains elements 1, 2, 3, 2, 4, 5, 3, 5, 6. So, this is equal 2 and 2. And then, this is equal 3 and 3. And then, last one, 5 and 5. So, the matrix is symmetric. So, a symmetric matrix is necessarily a square. So, it should be a square matrix. It's either 2 by 2, 3 by 3. Or a symmetric matrix may not have an inverse, but if an inverse exists, it is also symmetric. Okay. So, now, diagonalization of symmetric matrices, theorem, if a symmetric matrix, if A is symmetric, then any two eigenvectors from different eigenspaces are orthogonal. And then another, a matrix is orthogonally diagonalizable if and only if it is a symmetric matrix. So, itong mga theorems na to, of course, mapoprove natin yan mamaya. And then another definition, a matrix is orthogonally diagonalizable if there are an orthogonal matrix P with inverse of P or P transpose, or P inverse of P is equal to P transpose, and the diagonal matrix D such that A is equal to P times D times P transpose, or equal to P times D times P transpose, or P inverse. If A is orthogonally diagonalizable, then then A is equal to the transpose of P times D times P. Okay, so if A is orthogonally diagonalizable, then A is equal to the transpose of P times D times P, or equal to P times D times the inverse of P, or transpose. If it is orthogonally diagonalizable, then A transpose is equal to the transpose of P times D times P transpose is equal to P transpose times D transpose times P transpose is equal to A. So, A is symmetric. So, this is the definition of a matrix which is orthogonally diagonalizable. Okay, so let's proceed to the example. So, hindi ko na pinakita yung step by step, yung definition niya step by step. Sinabay ko na dito sa example. So, yung may mga check, this is the step. Okay. So, for example, I have here a matrix A. So, diagonalize A is equal to the matrix which contains elements 3, 2, and 2, 3. So, obviously naman na ang given matrix natin is a symmetric matrix because the same yung ating 2 and 2 here. So, first step, para ma-diagonalize natin tong matrix na to is to find the eigenvalues by solving determinants of A minus lambda times the identity is equal to 0. So, first step is, of course, I have here, ito yung original matrix natin. So, lalagyan lang natin yung lambda. Of course, itong dalawang to, magkakaroon lang ng lambda since si lambda naka-times sa identity which is, ang identity natin ay 1, 0, 0, 1. So, itong diagonal lang yung may 1. Kaya, pag minultiply natin siya sa lambda, ito lang yung magkakaroon ng lambda. Tapos, pag minus naman natin dun sa original matrix, so, ito 2 pa rin. Ito 2 pa rin. Kasi nga, 2 minus 0, 2 pa din. This one is lambda minus 3 equals, and another this one, lambda minus 3. Pwede rin namang 3 minus lambda. Equal lang, pareho lang yun kapag ka-factor natin. So, find the eigenvalues by solving determinants. So, we will find the determinants of this matrix. So, pag ginawa natin yung determinants niyan, equal yan kay lambda minus 3 times lambda minus 3 minus 2 times 2. So, determinants, pa-cross lang, equals. So, pag kinuha natin, or simplify, we will get lambda squared, nag-lambda sub 2 tuloy. Lambda squared minus 6 lambda plus 5. So, another, this one, ipa-factor natin. So, si lambda squared minus 6 lambda plus 5, pag finactor natin is lambda minus 1 and lambda minus 5. So, equate natin pareho by 0 para makuha natin yung value ni lambda. So, lambda minus 1 equals 0 is lambda equals 1. Ito naman, lambda minus 5 equals 0, we will get lambda equals 5. Next natin, since we already have the eigenvalues, so the eigenvalues are lambda equals 1 and lambda equals 5. Okay, so for our next step, for each eigenvalue, find its corresponding eigenspace. So, for lambda equals 1, so kunin natin yung null space niya. Null is equal to, null times A minus 1 times the identity. So, the A is the original matrix minus 1 times the identity. So, multiply lang natin si 1 dito sa ating identity. So, same pa rin yan. So, 3 minus 1, we will get 2. 2 minus 0, which is 2. 2 minus 0, 2. And then 3 minus 1, which is 2. So, this is the value or the matrix. And then, this matrix ay, para makuha naman natin si null space, ita-transform natin to reduced row echelon form. So, 2, 2, 2, 2. Ito siya, yung matrix. Para maging row echelon form, ito yung process, multiply the first row by 1/2. So, we will get 1, 1, 2, 2, and then add negative 2 times the first row to the second row. So, we will get 1, 1, 0, 0. So, the row echelon form, or the reduced row echelon form is 1, 1, 0, 0. So, a matrix with elements 1, 1, 0, 0. So, the null is 1, 1, 0, 0. The null space, so to find the basis is, we will get 1, negative 1. So, from here, para makuha naman si null space, si basis, so, mag-set lang tayo ng x sub 1 plus y sub 1 is equal to 0, and then x sub 2 is equal to x sub 2. So, para makuha si x sub 1, so x sub 1 is equal to negative x sub 2. So, mag-set lang tayo ng value. For example, x sub 1 is 1, or x sub 2 is 1. So, therefore, si x sub 1 is 1, and then the x sub 2 is negative 1. So, parang nag-set lang dyan ng values sa pagkuha ng basis. Next naman, for lambda equals 5, so, we'll get null A minus 5 times the identity. So, again, the given matrix A, and then minus 5 times dun sa identity matrix nung square matrix natin, which is 1, 0, 0, 1. So, okay, so 5 times 1, 0, 0, 1, and then i-minus natin dito, we'll get 3 minus 5, negative 2, and then 2 minus 0 is 2, 2 minus 0 is 2, and then 3 minus 5 is negative 2. And then this matrix, gagawin naman natin siyang reduced row echelon form. So, this is the process, ayan. So, that is the process for the reduced row echelon form. We will get 2, ito, negative 2, 2, 2, negative 2. Multiply the first row by negative 1/2. We will get 1, negative 1, 2, and negative 2. And then, add negative 2 times the first row to the second row. Makukuha natin 1, negative 1, 0, 0. So, yun na yung ating reduced row echelon form. So our null is 1, negative 1, 0, 0, and our basis is 1, 1. So, next natin is, so we have basis, ito yung una natin, 1, negative 1, and then yung isa, 1 and 1. So, ito yon. Yung basis natin, 1, negative 1, and then 1, 1. So, our null space basis. And, next step is to find the length or the norm of each basis or our vector, column vector. So, the norm or the length of 1, negative 1 is the square root of 1 squared plus negative 1 squared equals square root of 2. So, again, yung formula na na-discuss natin sa inner product and the norm. So, the length or also known as norm is square root of 2. Ganon din dito kay 1, 1. Ang distance niya, ang length niya is square root of 1 squared plus 1 squared equals square root of 2 din. So, next is to divide the column vector or yung basis natin by the length or the square root of 2. So, 1 divided by square root of 2 is 1 over square root of 2. Negative 1 divided by square root of 2 is negative 1 over square root of 2. Same with v sub 2. Magkakaroon tayo ng v sub 2 which is yung 1, 1 naman nating basis dito divided by yung norm niya din na square root of 2 din. 1 divided by square root of 2 is 1 over square root of 2 and then 1 divided by square root of 2 is 1 over square root of 2. So, to diagonalize basis of eigenvectors, so isi-set natin yung value ni P as v sub 1 and v sub 2. So, our v sub 1 is 1 over square root of 2 and negative 1 over square root of 2. Ito siya, dito. And then yung v sub 2 naman, nandito naman sa column na to, which is 1 over square root of 2 and 1 over square root of 2. Last step is state na natin siya as D or the diagonal matrix equals P times A times P transpose. So, yung P natin, copy lang, and then the A, which is our original matrix, times P transpose. Kinuha lang natin yung transpose ng P. So, ito na yung magiging natin, column, and then this one, ito na rin yung, ito na yung ating column 1, and then ito na yung ating column 2. So, kukunin lang talaga yung transpose. And then, multiply this matrices, we will get 1, 0, 0, 5. So, this is the diagonal or diagonalized basis for the given matrix, which is this matrix. So, again, the diagonalized matrix of A or the diagonalized basis of matrix A is 1, 0, 0, 5. So, ganun lang po mag-diagonalize ng matrix or the symmetric matrices.